Welcome everyone to the YouMakeup video question answering challenge. I'm Shizhe from Renmin University of China. I'll introduce the challenge on behalf of all the organizers, Lu Dan, Ning Li, Wei Ying, and Qin Jing. The schedule of the challenge is as follows. First, I'll introduce the YouMakeup challenge, including our motivations, task introductions, and briefly summarize the participations and results. Then different teams will present their solutions in the challenge, including our strong baseline models and the solutions from the winner teams. Video semantic comprehension has been a hot research topic in recent years. Many datasets have been proposed for video understanding, which can be generally divided into two types. The first type focuses on open domain videos. They often contain broad categories of activities and only provide coarse-grained annotations, such as action labels in coin dataset. The second type focuses on specific domain videos, usually the cooking domain. Though cooking events are of rich semantics, they contain large varieties in visual appearances of different cooking videos, such as foods and kitchen utilities. Therefore, they might not need fine-grained discrimination abilities to understand different videos. So currently, fine-grained semantic comprehension has not been well explored yet. So in this YouMakeup challenge, we aim to provide the benchmark for fine-grained action understanding. We propose a new specific domain video, the makeup activities. Comparing with open domain videos or cooking videos, makeup activity is fine-grained in nature. A makeup activity is determined by actions, products, tools, and facial areas altogether. Take the apply action as an example, as shown in this image. Combining with different products and facial areas, it will generate a large amount of different makeup activities. Different activities may use products or tools of similar appearances and apply in overlapped or adjacent facial areas. These diverse activities can be similar to each other, but with at least one subtle difference. Therefore, it requires fine-grained reasoning in both temporal and spatial dimensions to distinguish different activities. So we collect a large-scale makeup dataset called YouMakeup dataset from YouTube. It contains 2,800 makeup videos, spanning more than 400 hours. And we provide each video with fine-grained annotations, including the start and end time steps of each makeup step, the related facial areas, and the spatial groundings of facial areas on the video. And finally, the step descriptions. Some statistics of our YouMakeup dataset are as follows. The videos are of various lengths, which reflects the complex situation in real world. Step numbers of these videos are very different. Each video has 10 steps on average, indicating the complex of makeup activities. This is a comparison between YouMakeup dataset with other video datasets. We can see that the YouMakeup dataset is large in scale and contains richer semantic annotations. We propose two tasks to evaluate fine-grained action understanding abilities from two aspects. The facial image ordering task aims to understand the effects of actions on different objects, and the step ordering task aims to understand cross-modal relationships between video and language. I will explain the two tasks in the following. In the facial image ordering task, the model needs to sort a set of facial images from a video into the correct order according to the given step descriptions. We provide action descriptions in correct order and the shuffled facial images. The model should select the correct order from the four candidates. The task requires the model to understand and track changes that action descriptions will cause to the face. However, these changes can be very subtle. As shown in the case, both image A and D has redness on the face, but image D has more even skin tone and shadow on the edge of face. Models need to detect the subtle difference between them to find the right order. And the model should discriminate makeup changes from irrelevant changes, such as pose. Besides, combining action descriptions and images is crucial to solve the task. As shown in this example, we can hardly decide the order of image C and D when only refer to the image. But the step captions can provide clues to decide the correct order. The second task is step ordering. It is to sort a set of action descriptions into the correct order that these actions are performed in the video. We provide a video and a set of shuffled action descriptions. The model needs to select the correct order from 4 candidates. To solve the task, the model needs to build fine-grained cross-model semantic alignments between video and language. Compared with previous video text cross-model localization task, the novelty of this task has 3 aspects. Firstly, different actions share similar background contexts. Thus, it requires the model to specifically focus on actions and action-related objects instead of correlated but irrelevant context. Secondly, since different actions contain dedicated differences, the task demands fine-grained discrimination in temporal and spatial dimensions, such as locating the facial areas and detecting the makeup tools. Finally, our task goes beyond mere single text-to-single video localization and requires long-term video and textual understanding. Relations between different steps can be beneficial. Though our challenge is newly released, we are very happy to see that there are 17 teams participated in the challenge. 1 team submitted results on facial image ordering task, and 2 teams submitted results to the step ordering task. The winner of facial image ordering task goes to Yajie Zhang and Li Su. The winner of step ordering task goes to Kun Liu and Hua Dongma. However, since the 2 tasks are very challenging, our provided baselines are still very strong compared to results from participants. Therefore, we are first to explain our baselines in details, and then followed by the winner solutions of participated teams. Congratulations to the winners, and thank all the organizers for the success of the challenge.